So, when you're building with AI, your tools are only ever as good as the contracts that define them. You get these right, and you've got a solid, predictable system. But if you get them wrong, you're in for a world of pain. Today, we're going to talk about how to design schemas that actually last and turn all that potential chaos into predictable power. And, this quote really nails it. A poorly defined tool contract isn't some minor bug. It's literally a ticking time bomb sitting inside your application. It's where all those unpredictable errors, security issues, and super frustrating debugging sessions come from. So in this explainer, we're going to diffuse that bomb. All right, first up, let's really dig into why schemas matter so much. We'll look at the two very different roads your project can go down. And as you'll see, the quality of your contract is pretty much the biggest factor in whether your tool becomes a reliable workhorse or just a constant headache. What's so stark here is the contrast, right? On the left, with good schemas, you're getting automatic validation, clear documentation that works for both people and the AI model, and you can evolve your tools safely. It all leads to type safety. It prevents runtime errors. It's just better. But on the right, it's chaos. Bad schemas lead straight to runtime failures, the model hallucinating parameters that don't exist, breaking changes, and even security holes because your inputs aren't properly locked down. So, how do we dodge all that chaos and stick to the reliable path? Well, the answer is all in the anatomy of a really well-structured tool contract. Let's break down the blueprint for building secure, predictable AI functions. At its core, a tool contract isn't just code. Think of it like a formal agreement. It lays out the tool's name, a description that the AI can actually understand, and, most importantly, the exact shape of the inputs it needs. It's basically the API contract for your AI. Okay, let's make this real with an example. What you're seeing here is the complete tool contract for a function called send email. This whole block of code is what the AI model is going to use to figure out how to call your tool the right way. Now, let's zoom in on the most important piece, the input schema. So, inside that schema, we have the properties block. This is where we define every single parameter. See here, the toField is an array of strings, but not just any strings. They have to be in an email format. The subject is a string, but we've capped it at 200 characters, and the body is just a plain old string. Every parameter gets a type, it gets constraints, and it gets a description. And this little bit right here, this is one of the most powerful parts, the required array. Just by listing to, subject, and body, we're telling the system that this tool absolutely cannot run unless it has these three things. This one simple line prevents a massive category of errors before they can even happen. Okay, so knowing the parts is one thing, but applying the right design principles, that's what makes a schema truly robust and, future-proof. So let's get into the how-to. First things first, you have got to be specific. A vague schema like type is string is, well, it's almost useless. A good schema, though, adds a format hint like email and can even throw in a regular expression pattern for really precise validation. That specificity is what gives you powerful automatic error checking. And that specificity needs to apply to all your inputs. You should constrain everything. If you have a fixed set of choices, use enums, like for docs, code, data. That stops typos and invalid options cold. For numbers, set minimum and maximum values, and limit your string lengths to prevent abuse or buffer overflows. Seriously, these constraints are your first line of defense. Now, this one might sound kind of obvious, but it is so critical. Your descriptions are not just for humans. The AI model actually reads these descriptions to figure out how to generate the right arguments. So a good description that explains what a parameter does, gives an example, maybe clarifies an edge case, that will dramatically improve how reliably the model calls your tools. Awesome. So you've designed a perfect schema for today. But what about tomorrow? Your tools are going to need to change, and you need a strategy to manage that evolution without breaking everything. And that's where semantic versioning comes in. It's a really simple, clear system. A major version bump means you've made a breaking change. A minor version means you've added a new feature, but it's backwards compatible. And a patch is just for bug fixes. This tells everyone using your tool exactly what to expect from an update. It's fantastic. Which brings us to probably the most important rule for evolving your tools. Never ever add a new required parameter. If you need to add a new field, you have to make it optional. This is the absolute key to making sure that all of your existing integrations keep working without failing validation. And always remember, the schema is your blueprint, but your server is the builder that has to enforce it. The flow should always be the same. First, validate any incoming request against your JSON schema. Then, apply your business logic, like checking user permissions. After that, sanitize the inputs to stop things like injection attacks. And if anything fails along the way, return a clear, helpful error message.
Whew, we have covered a lot of ground, from components to principles to versioning. But if you remember only one single thing from this entire explainer, please make it this next point.
The golden rule is this: start strict. Define your constraints as tightly as you possibly can. It is always easy to relax a schema later, like, say, increasing a string's max length. But it is incredibly difficult, and usually a breaking change, to tighten up a schema that was too permissive to begin with. So, start with a fortress. So as we wrap up, I want you to think about the tools you're building right now. Go take a look at their contracts. After everything we've covered today, ask yourself, is your schema a clear blueprint for success, or is it a hidden landmine just waiting to go off? The choice really is yours.